So you're getting into electronics, right? Then you have definitely seen one of these little plastic grids. This, my friend, is a breadboard. And I promise you, it's one of the most powerful tools you're going to have. So today, let's just dive right in and demystify this thing. We're going to cover everything from what it is to how you can start building your very first awesome circuits with it.
Okay, but first things first, that name, breadboard. Why in the world is it called a breadboard? I mean, it's plastic. It has nothing to do with baking. Or does it?
Well, believe it or not, the name is completely literal. Back in the day, the original inventors would literally grab a wooden board for cutting bread, hammer in a few nails or screws, and then wrap wires around them to build out their circuits. It's that simple. And the name? Yeah, it just stuck. All right, so here's what we're going to cover today. We'll start with what a breadboard actually is, take a look at its anatomy, figure out how the connections work inside, share some best practices for building, and of course, go over some essential safety rules. So let's dive right in. What even is a breadboard? Really, the best way to think about it is like a reusable canvas for your circuit ideas. It's where you can bring them to life. And here's the key thing, the real magic of it. A breadboard lets you build temporary circuits, and you don't have to solder anything at all. You can just plug your components in, see if your idea works, and if it doesn't, no big deal. You just pull them out and try something different. It's all about being able to experiment freely. No fuss, no permanent connections, no mess. And that's why they are just perfect for beginners. You get to run quick experiments, you can swap parts around in seconds, and they're super cost-effective because you can use them over and over again. This is basically your playground. It's how you test and fine-tune an idea before you decide to make it permanent on something like a printed circuit board or PCB. Okay, you ready? Let's take a little tour of the breadboard's anatomy. I know, looking at all those little holes can feel a bit overwhelming. But trust me, once you understand the layout, it's actually incredibly simple and logical. So let's start with the bird's eye view. You can pretty much break the board down into two main zones. You've got these long strips on the sides, those are the power rails, and then you have this big grid in the middle. That center part, that's your main stage. It's the prototyping area where all the action happens. Let's zoom in a bit on those strips on the side. We call these the power rails, and their job is exactly what it sounds like. They deliver power to your whole circuit. Think of them like the main power lines for your project. You'll usually have a red line for your positive voltage and a blue or black one for ground. Okay, now for the main event, those terminal strips right in the middle. If you remember one thing, remember this. Every horizontal row of 5 holes is connected together electrically. That's it. So if you plug something into, say, hole A in row 15, it's automatically connected to holes B, C, D, and E of that exact same row. That's the big secret right there. But hang on, what about that big canyon running down the middle? That's the center divider, or what some people call the ravine. And it's not just empty space, it's super important. It creates a break completely separating the left side from the right side. And why does that matter? Well, it's crucial for things called integrated circuits, or ICs, those little black chips. They need to sit right across that gap, so their legs on one side don't accidentally touch the legs on the other. So, okay, we know the rows are connected, but how? What's going on inside this thing? Well, let's pull back the curtain and take a look at the simple bit of genius that makes this whole thing possible. And there it is. See? From the outside, all you see are plastic holes. But if you were to peel back that sticky foam on the bottom, you'd find rows of these little metal clips. When you push a wire or a component leg into a hole, one of these clips just grabs it. It makes a solid electrical connection with anything else plugged into that same clip. It's so simple, but so effective. Just a brilliant piece of design. This actually brings up a really important term in electronics, a node. All a node is a point in a circuit where a bunch of things connect together. So on a breadboard, each one of those little 5-hole rows, that's a node. It's a pre-made connection point just waiting for you to use it. Okay, so we've got the how it works part down. Now let's talk about how to actually build something. And trust me on this, keeping your circuit neat and tidy isn't just about making it look good. A clean layout will make your life so much easier when you have to track down a problem. Really, it just comes down to a few good habits. First up, always use the power rails for your power and ground. Don't be tempted to just stick them somewhere in the middle. Second, use the right colors for your power wires. Red for positive, black for ground. It's a universal convention for a reason. It'll save you a ton of headaches.
Third, keep your jumper wires short and flat against the board. You want to avoid that crazy rat's nest of wires that's basically impossible to debug. And finally, just like we talked about, make sure those ICs are straddling that center divider.
And last but definitely not least, before you even think about plugging anything in, we need to talk about safety. This is probably the most important part of the whole thing. The rules are super simple, but they are absolutely non-negotiable. They're going to protect you, and they're going to protect your parts. Okay, rule number 1, the golden rule, no exceptions. Before you change anything on your circuit, adding a wire, removing a component, even just wiggling something, disconnect the power. Every single time. Seriously.
Next up, those little black chips, the ICs, you gotta be gentle with them. They are incredibly sensitive to static electricity. I'm talking about that tiny little zap you can't even see or feel from your fingers. That's enough to completely fry them for good. So try not to touch their little metal legs, especially when the circuit has power. All right, next, pay attention to polarity. What does that mean? Well, some components are basically one-way streets. Think of LEDs or certain capacitors. They have a positive side and a negative side, and you have to plug them in the right way. Get it backwards, and best case scenario, it just won't work. Worst case, you might hear a sad little pop, and that's the end of that component.
And this last one, this is just good old-fashioned common sense. If you see smoke, or if you smell something burning, what we lovingly call letting the magic smoke out, don't panic. But don't hesitate either. Just pull the plug. Disconnect the power immediately. That almost always means you've got a short circuit somewhere.
And that's it. That's the breadboard totally demystified. It's not some confusing block of plastic anymore, is it? It's a powerful tool, a blank canvas that's just waiting for you to turn your ideas into something real. So really, there's only one question left. What are you going to create first?